for this video, we'll be looking at the construction of polygons. Alright, so the last video we looked at the construction of triangles. Now today we're going to look at construction of polygons. Polygons in a sense that we're going to look at how we construct like a pentagon, hexagon, decagon, etc, etc, etc. Alright, we have three methods that we will be focusing on today. And that method one is where we're constructing a polygon or polygons sharing the same base. So we're constructing the polygons sharing the same base. For this particular example, we'll be looking at a pentagon and an octagon sharing the same base. And these are what we refer to as regular polygons. Now, regular polygons are polygons with all the sides measuring the same length. So they have the same length. As well as irregular polygons are polygons with the lengths having different dimensions. Alright, so the ones we're focusing on today are regular polygons. So for this method one, we have here, we're going to be constructing the pentagon and the hexagon, and the base side in this one is 60 millimeters. So let's go. We go to draw line, and we want to draw this line being 60 mm. So we have that line there, 60 mm. You notice that I'm working first with my construction lines. All right. So we're going to, of course, any line that you draw must be referenced. All right. So this here is A, and we have B. Let me copy this, put it over here. So we have line AB. Line AB. So now that we have line AB, right? What we want to do is we want to erect a perpendicular line from the center of the line AB. So we're going to draw a line, and we will get a triangle. Once we get a triangle here, it means that this is the midpoint. All right, and we extend this line up. What then is the length of this line? Well, this line here is relative. You will just extend this line to where it suits you. Okay, now from A, we're going to construct or draw a line at 45 degrees, right? So we want a line to be drawn at 45 degrees. 45 degrees. All right, we can trim there, and we will put a point right here. So we take a point, and we drop a point right there. Where this point is, because this is the 45 degrees, where this point is, we will call that point 4. So this here will be our point 4. All right. Now we need from B a line that is at 60 degrees. So 60 from 180 gives us 120. All right. That means we want a line, notice from here, see that 90 degrees. So we want 120 this way. Because if we wanted the 60, this would be 60, but we don't want 60 over there. Right? We want the 60 over this side. So therefore, we want a line that is at 120 degrees. 120. Good. All right. So we know we have this line here at 120. All right. We're going to point, and we put a point right there. Now to make the thing neat, we will just trim there. Now this point here, now we're going to call that point 6. So we have 4, and now we have 6. So this will be 6. So you might say, why do we number it 4, 6? Why not 4, 5? Because we are going to have to find the midpoint between 6 and 4 for us to get 5. All right, so what I'll do, I'll just draw a line from 4 and 6. then I'm going to find the midpoint of that line. So I'm just going to type point and find the midpoint is right there. So this is where we would find 5. So let me just copy 4 and 5. This is where we'll find 5. 5. Now, if we want a regular hexagon, and you know hexagon is a 6-sided figure, then we'll be interested in this point. If we want a regular pentagon, which we do in this case, we are interested in this point, number 5, because 5 sides give us the pentagon. 6 sides give us the hexagon. So you might say, what about the 4 side? Now, if I want a square, then I would use this point here. So the square would give me 4. All right, 4 would give me the square. All right, so the distance between 4 and 5 is similar to the distance between 5 and 6. So what I'll do is I can use quick dimension and find out what is the dimension between here, and we'll get 11. So between the centers it's 11. So what I could do is I could copy. So I'm going to copy this point. So I'm going to copy this point and come up 11. So that point there, this point here would be 7. So I'm going to have to extend this line some more. So I'll extend that line some more. So we know that that point there is 7. Oops. So that is 7. So if we wanted a heptagon, then we'll put the point here. But what do we want? We want a octagon. So let's copy this again. And we're going to move it up 11. All right. And we copy this. And this is where we have 8. Good. Now, so what we see here is that we are interested in 5. Let me call it 5. We're interested in 5. What? We are interested in 5 and we are interested in 8. So what we do now, circle 5 and we open it up to either A or B. Any one of them will yield the same result. Right? So we have this circle there. What we want to do now is to get the length of AB. So we go to circle and we put it at A and extend to B, or vice versa. Put it at B and extend to A. Now, this point right here, let me type point. This point there, if I connect a line from here to there, you will realize that the length of AB is similar to the length of A and that point here. So let's call this point E. That this point will be E. So I'm going to copy this. This point here will be E. Because it's a pentagon, so it has 5. So A, B, C, D, E. Alright? Then what we'll do with this circle, we'll move it from the center here. Okay, so this point here is off. Alright, there we go. Alright? Now, so what we do here is we are going to copy the circle and place it at that point. And now we type point, P-O-I, and we put the point there. Of course, we connect a line from there to there. Alright? So we see the polygon, we're making progress with the polygon, right, with the pentagon, right? So that now would be D. So E is here, and this will be D. And finally, we move the circle from the center there to D and type point, and this will be the point, and we connect B, C, D. Alright, so we copy this, and we will have C right here. Okay, and there we have it. Now what we can do is break. So we want to be able to show our construction, so we break, and so we see that this is how we establish our arc. Alright, copy all of this, and we convert it to outline, move it from a construction line to outline, right? Because it's now the finished product. So we want, this is the one of the finished product that we want. All right, so we have just constructed the pentagon, right? And it's on the base AB of 60 millimeters. So we want to now construct the octagon. We want to construct an octagon sharing the same base. So what we do, we go to draw a circle, and since we want octagon, we will put the circle at the center for the circle at 8. If we wanted a heptagon, we'll put the circle at 7. If we wanted a hexagon, we'll put it at the circle center at 6. So we want 8, so put it here, and would open up to either A or B. So open up to either A or B. Alright, so now once we have that, okay, let us move this. Let's move this about there. Alright, so now that we have the outside circle, we will do the same thing. Remember what we did before? We're going to draw a circle with the center at either A or B, or open up to A or B. Right? Now, what you find out is that this point here, and type point, PO, this point here would be a point that we need. Alright? We can take this circle and put it over at B, and then this point here is a point that we need. We take this circle and move it there, point, we need it there. Take the circle, move it here, point, and we need that there. Take the circle, move it to this point, and right there. Take the circle, move it to this point, and right there. Good. So let's go to break, and we break that. So we just get a construction line there. And what we do now is we, from A, that's 1, 2, 3, 4, 5, 6, 7, and AB being 8 sides. Right? So we have our 8 sides. 1, 2, 3, 4, 5, 6, 7, and AB being 8. So let's convert that to outline. And there we have our hexagon. Alright, so of course we have to label our hexagon. We have to label it, right? So if the first one is A, B, C, D, E, then we can say A, B, P, Q, R, S, T, V. Alright, so A, B, C, D, A, B, C, D, E. So this is F, G, H, I'm not putting I, so I'm just going to put J, K, L. Now what you can see that this point, we missed this point, that should be there, and this should be there. Alright, and there we have it. Leader line. This one is the pentagon. And this one is the octagon. All right, and there we have it for the method 1, construction of a polygon sharing the same base. So we're still constructing polygons. Now we're going to look at method 2. So with this method, we are going to be implementing the mathematical expression 360 degrees divided by n, with n being the number of sides in the polygon. Alright, so if we should divide 360 degrees by the number of side the polygon will have, the angle that we get will be the external angle, and the external angle is what we'd use now as the basis of constructing the polygon. We have two examples here. Now we will be given the length of a side, and in this case the length of a side we're going to use is 60 millimeters, right? So the length of a side we're using is 60 millimeters. We are going to be constructing two. I'm going to use two just to show you how we would actually get it. Now we're going to be constructing a pentagon and an octagon again. So we're looking at the pentagon again and the octagon again. Now 360 degrees, what is n in this case for the pentagon? A pentagon has 5 sides. So therefore we divide 360 degrees by 5, which will end up with 72 degrees. So 72 degrees is the angle that we need to construct this pentagon. Over this side, we have an octagon. An octagon has 8 sides. So it would be 360 degrees divided by 8, and in this case we'll get 45 degrees. So let's go now with the construction. Alright? So we're going to look at the pentagon first. First thing we're going to do is we're going to draw a line, and this line, turn on ortho, this line is 60 mm. Alright, so 60. And of course, with everything that we do, we want to reference the line. So this here, let's use A, copy this, and this will be B. Let's move on, copy. A, B. Alright, so we have our line AB. Now, how do we implement the 72 degrees? How do we get the 72 degrees? Now, you can get the 72 degrees at A, or you can get the 72 degrees at B. Either way, it works out the same way. So, with with polar tracking on, we come at B, and we want, how much do we want? 72 degrees. So we want 72 degrees. There is 72 degrees. And what is the length of the side? The length of the side is 60 mm. Alright? So this angle here, this angle right here, right? If I should measure from here to here, that angle there is 72 degrees, and that is the angle that we need, right? So we have 72 degrees and this is 60, so let's call this C. So this point would now be C. That is now C. So there we have it, A, B, C. I'm going to pull this down a little bit, move it down here just a little bit so we have more space to construct our pentagon. Now we have the line A, B. So these two lines we're going to brighten because they are actually a part of the finished product. Alright, so we have line A, B, C. Now what we want now, we want to be able to construct the others. Alright, so what am I going to do now? I need to get the circle. I need to get this circle. How do I do that? Center line here, and I want a perpendicular line from here. So from the center here, I want to establish a perpendicular line. So this line there is perpendicular, right? This line is perpendicular. So where this line meets this, we're going to type point. And that point now is where we need the center of a circle that will circumscribe this pentagon. So we go to circle, center here, and we can open it up to either we can open it up to C, B, or A. Anyone, and it should touch all 3 points. Notice that it touched all 3 points. Now what we're going to do, we're going to go for circle, put it here at A, open it up at B, and we type point, P-O, and it's right there. Alright, we can take this circle, move the center from there, and we are complete. So what we do, we connect this, there, there, as well as we connect right here. Alright, so with all of these connected, convert them to outline. Alright, and what we do now, we just tidy up the work by break. Alright. Alright, and there we have it. So we have constructed the pentagon. This is how we construct a pentagon using the method 360 degrees divided by n, and n is the number of sides we want. Let's try this again now with the octagon. Alright, so with the octagon, let's go again. We draw our line. So this line is supposed to be 60 because the length of the line given is 60. So we'll copy this here, and let's say that this here is PQ. Alright, so we have PQ. So here we have a line PQ. Now the angle that we want right here, notice that if we divide 360 degrees by 8, we're going to get 45 degrees. So I want 45 degrees right here. So I want 45 degrees. So that here we have 45. That's 44. 45. So 45 degrees, and we type 60, enter. Alright? And that is what we have. So PQ, copy, PQ, R. So we call it R. So we have line PQ, and we have line QR. Let's make this outline. all right? Because those are lines that are part of the required um, octagon, all right? So again, we get a perpendicular line here, and we want a perpendicular line here, all right? That is not perpendicular. Let's go again. All right, so this is perpendicular now. All right, so there we have the perpendicular line, and we type point there, and we go for circle. So open up from R, Q, or P, any one, right? So it should drop on all the sides. Once we do that, again, we go for circle, P to Q, and you know this is a point, right? So we type PO, and a point is right there. We'll move the circle, put it here, point, and point is there. Move the circle, point, the point is there. Move the circle, there. A point is here. Move the circle, and a point is there. All right, so let me go to brick. And what I want to do is I want to just move all of this. Am I missing anything? Let's move and bring this down here. All right, so bring that down there. So we're just going to connect all the points now. All right, so there we have it. And we convert this to outline. All right, and we have our um, octagon there, and this angle on the outside here. Let's delete this. So this angle on the outside here should be 45 degrees. Okay, 45 degrees. See that? Right. So this is the exterior angle, 45 degrees, which we get because 360 degrees divided by 8 would give us 45 degrees. All right. And that is that for method number 2. And of course, you know that we should, by right, label our side. So we have P, Q, R, S, T, U, V, W, and would actually label our sides. All right. Construction, we'll be looking at constructing a polygon given the diagonal. All right. So we looked at one, constructing a polygon given the length of a side, on which we will construct more than one polygon sharing that same base side. 2, we construct a polygon using the mathematical expression 360 degrees divided by n, and n there meaning the number of sides. Now for method 3, we are going to be looking at how to construct the polygon given the diagonal. In this case, we have a diagonal here which measures 130 millimeters. Now, what we want to construct here is a regular pentagon, and a pentagon has 5 sides. All right. Now, the first thing to do is to get our circle. So, circle, and we want a center there, and this circle, the diameter is 130. All right. So here we have our circle, diameter 130. Let me move this, bring it a bit about here. All right. So put it about there. Now let's just check to see. All right. And this there, it says 130. So we know that the diagonal here is 130. All right. Now what we're going to do, we're going to draw a line through the center of the circle. We draw a line through the center of the circle, and of which we will call this side X, we'll call that side X, and we call this side Y. So we'll call this side Y. So a diagonal is referred to as XY. Now, after establishing XY, remember that what type of polygon are we constructing in this particular? It's a pentagon. A pentagon has 5 sides. So the diagonal will be divided into 5. Now, if we wanted a decagon, then the XY, which is our diagonal, will be divided into 10. If we wanted a hexagon, then the diagonal would be divided into 6. Now, so we're going to divide this into 5. So we say div divide, click on the line, and we're going to type 5 because we want 5. All right. So here we have 0, 1, 2, 3, 4, 5. Now for this construction, the point 2, this point right here, 2, is important to us. All right, so let me copy this. And 2 will be this point. 2. So this point here, the second point, 1, 2, we are interested in this point. What are we going to do now? We're going to draw a circle. So from Y, we open up to X, and we have this circle there. Good. We repeat from X, open up to Y, and we have this circle there. Now what we want to do, I'm going to type break, and we want to BRE, and we want to get rid of that there, and we want to get rid of that there. So what we see now is that with our point here at Y, we open up to X and we scribe an arc. With our point here at X, we open up to Y and we scribe an arc. Now we're going to draw a line from that point there to the point 2. Now once we have that, I'm going to extend this line, extend, and I extend it. It touches the circumference of the circle right here. Now this point here, let me call this S. Let's call this point S. So between S and X, it's a length. This is the length of a side required. All right, and I think you understand exactly where we're going to go with this now. So once we have this side, then we go to circle, put it here at S, and we open it up to X. Now this point here, is also the length of a side. And if we're supposed to move this circle from here to there, now this point to there is the length of a side also. And if we move this to there, then we can say from here to there to there, and we would have completed the construction. So go to break because we want to make sure that our construction lines are showing, so that we can get all the marks possible, right? Anybody who's marking your assignment will see that you have done the necessary geometric constructions, and you are awarded the mark as such. All right. So we have S. Let's call this T. Let's call this W. And let's call this Q. All right. So we have the pentagon. And remember, with these, all I'm doing is just simply working with my layers. And again, I will show you how to set up your layers. Just the basic things that you need for your drawing, for your geometry drawing. All right, and here we have it. 3 methods of constructing the polygon. One, when you have more than one polygon sharing the same base. Here we have a pentagon sharing the same base, base AB, with an octagon. All right. The next one, method 2, by using the mathematical expression 360 degrees divided by n. So in this case, we wanted a pentagon. So once we draw the line AB, we find 72, because 360 degrees divided by 5, we get 72. So we want an angle of 72 degrees on the outside. And we get a perpendicular line, when it intersects, then we draw the circle. The method 3, we are constructing a pentagon, and we were given the diagonal of 130 millimeters.